this lesson, we are going to discuss lines in the coordinate plane. In particular, we're looking at equations of lines and their effects with the coordinate plane. Two simple objectives. After we create the equation of a line, we want to be able to graph it. Whether that equation is point-slope form or slope-intercept form, we want to be able to graph lines. And secondly, we can analyze the equation to be able to determine if we have parallel, intersecting, tying into our previous lesson, possibly perpendicular, or coinciding lines. And so we have just two things that we have to remember. In your earlier classes with Algebra 1, you of course learned about point-slope form and slope-intercept form. This is intended to be a quick review over those things that you've done before. Ultimately, we'll remember that equations have many different ways that you can write them up. The two most popular ones are point-slope and slope-intercept, but I want to quick remind you that neither one of them is any good at all for a vertical line. Point-slope and slope-intercept both use the slope of a line. A vertical line has no slope, so how could you use something that doesn't exist? Vertical lines have a different rule that you just have to remember. And if you'd like to pause the video and write down a bunch of notes, you can. The important characteristic, though, that we're noting, the point-slope form gets its name because it tells you exactly what it is you need to write the line. You need to know one point anywhere on the graph of the line. That point is x1, y1. You also need to know the slope. We'll use the letter m to denote it. And if you know the slope and you know a point anywhere, you're able to write them out so that it looks like this. Second form of a line is slope-intercept. And again, it gets its name because it tells you exactly what you need. You need to know the slope, you need to know the y-intercept. And it would have this format. Just to reiterate, it's been my experience that students tend to remember slope-intercept form, and they don't remember point-slope. That's unfortunate because I also think point-slope is vastly more useful. It's just a simpler one. Well, perhaps simpler is the wrong word. Its uses go beyond just one point because point-slope is only good if you know what the y-intercept is. A lot of times you won't know that. Point-slope would work anytime. Also mentioned that vertical line has a different rule. Remember, vertical lines are the format x equals. Horizontal lines have the format y equals. And a lot of times students get those two mixed up. They tend to forget this fact. If you have your graph and you have a horizontal line, you'll notice that it has the y-intercept because it crosses the y-axis. Well, because it's crossing the y-axis, that's what makes it of the format y equals. And that height, whatever it is, let's say it's a height of 5, that would be y equals 5. If we have a perfectly vertical line, that one does not have a y-intercept. It only has an x-intercept. Because it crosses the x-axis, that's what makes it of the format x equals. And so this could be something like x equals 3. It's very common for students to get those two backwards. You shouldn't. Make sure you, however you remember it, you should be able to make sure that you always write down horizontal lines with the form y equals. Vertical lines always have the form x equals. So, first one, write the equation of a line. Well, we have a slope of 6 passing through the point 3, -4. I just want to emphasize again, if you're given a slope and you're given a point slope form is easier. Since we're using point slope form, you should be able to just write this thing down based off memory. You should not have to look it up. Once you've got it written down, just plug in the pieces that you know. What is your y coordinate? -4. What is the slope? What is the x coordinate? And that's our answer. We're done. In general, though, you see how we had subtracted -4? That could be confusing for people, so anytime we have subtract a negative, it's more common that we would rewrite it as adding a positive, just because that looks a heck of a lot simpler. But there, we're done. Right? Same type of problem. Write the equation. We have an x-intercept of 3. We have a y-intercept. And we're using point slope form. What's our challenge here? We're not told what the slope is. Well, since we don't know what the slope is, of course, we're going to have to figure it out. And it may be beneficial to put in just a quick sketch. We have an x-intercept of 3, a y-intercept of -5. That's our line. And we want point slope form. So what's the slope of that? We know slope is rise over run, so how much is it rising? That's 5. How much is the run? Just over 3. So we have rise over run, 5 over 3. Now that we know the slope, and we could use either point we want. The x-intercept is telling us that we have the point 3, 0. We can use that one if we want. The y-intercept is telling us that we have the point 0, -5. We can use that one if we want. It doesn't matter which point we use. So pick one. Do you want to use 3, 0, or do you want to use 0, -5? Choosing 0, -5, we would have point slope form again. And now just plug them in. Y minus y1. Y subtract the -5 would be add 5, just like before. We calculated the slope as 5/3. And we've got x minus 0. That's point slope. We're done. Okay, what about slope-intercept form? We have a slope passing through a point, and we want slope-intercept form. Well, there's a really important characteristic to note here. The slope is 0. What does that mean? That makes it a horizontal line. We know horizontal lines always have the format of y equals. Y equals what? Well, if we're talking about y equals, we're going to look at the y coordinate. Done. We have the equation of our line. Right, we know that we need to have slope or point slope form. And just putting in pieces that I know, I'm looking at this point right here, Because it doesn't have negatives, I'd rather work with that one. It's just my brain works better that I don't have to switch a negative to a plus sign. I just like that better. So I'm going to put in my y coordinate of 2, my x coordinate of 1, and the only other thing that we're missing is slope. So what is the slope between those 2 points? Well, we know slope is rise over run, y2 minus y1 over x2 minus x1. 2 minus 2, 1 subtract negative 3, 0 over 4 gives me a slope of 0, so it's there. And we've got it written out in point slope form. Of course, this is something that we would never leave it this way. We'd always simplify this particular bit because 0 multiplied by anything is just 0. Add in 2, and we have the line for a horizontal. We have the equation for a horizontal line. Y equals 2, and we'll emphasize that that comes from the fact that both of the y coordinates are 2. Because the y coordinate does not change, we could very rapidly get the fact that y equals 2. Of course, the second skill we want is to be able to graph. Graphing the line is nothing more than counting. It's just knowing where you're supposed to start and how to count. In particular, you should look at this equation and recognize that this is this is slope-intercept form. By looking at the equation, you are supposed to recognize positive 1 is the y-intercept, which tells you you could put down a point for the y-intercept. Moving forward from there, slope is 1 over 2. Since slope is rise over run, that's a rise of 1 and a run of 2. We can just count from this point forward and start plotting points over and over. From our y-intercept, up 1, right 2. 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 And you'll notice I kept doing that all the way to the edge of the graph. A lot of times students want to put down 2 points and then just say, oh, I'm going to connect them. You should put down as many points as fit on your graph. And of course, we should be able to recognize also that up 1, right 2 could go backwards, left 2, down 1. So left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2, down 1. Fill up our entire graph with as many points as we can, connect all the dots, and we get a pretty accurate picture for our line. And it was based on nothing more than counting. But you have to know where to start, and you have to know how to count. It's the exact same skill if you have point slope. In this instance, we would have to recognize these pieces give us a point. Changing the sign on them, this gives us the point -4, +3. And we know that we need to change the sign because the actual format is y minus y1. It's already built on subtraction. X minus x1. Well, to switch it from negative to positive, we know that we would have to subtract off a -4. Ultimately, whatever sign you see in the equation, just change the sign. Well, this is where we started them. We have the point, -4, left 4, up 3. That's where we will begin. And now that we've got it, we'll just look at the slope. A slope of -2 on the fraction, that's -2 over +1. And so we can just count. Left 2, I'm sorry, it's rise over run. So this is saying down 2, right 1. So down 2, right 1, 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 down 2, right 1. Continuing in the opposite direction, up 2, left 1. So up 2, left 1, up 2, left 1, up 2, left 1. And we've got enough points now that we can connect the dots. And we've got our line. What if it's y equals -3? Remember, y equals, is that horizontal or vertical? That's a horizontal line, so with the height of -3 gives us our starting point. We need a completely horizontal line. And we're done. And looking at your work, we correctly identified, starting off at the y-intercept of -3, and recognizing the slope is 2 over 1, we were able to count up 2, right 1, up 2, right 1, up 2, right 1, 2, right 1, and just continuing, down 2, left 1, and I don't actually need to have those points written down, I was just using them to help me count. We've got our points all laid out, got them all, and we've got our graph. Do the same thing. Checking your work. People correctly identified. We are looking at these pieces of information. When we have these in our format, we need to change the sign on both of those. The point where we actually start would be -2, changing it from positive to negative, and +1, changing it from -1 to +1. This is our starting location. At the point, -2, 1. Now that we have this point located, we're able to identify the slope. The slope is our counting. Down 2, right 3. So just count. Down 2, right 3 gives us the next point. Down 2 and right 3 gives us our next point. Down 2, right 3, and that's enough that we can start seeing the pattern develop. Continuing over, we could have also written that slope of -2 over +3 as +2 over -3. That's still a -2/3. And with that interpretation, using this format, we'd be able to see up 2, left 3, up 2, left 3, and continue that pattern over to the edge. The next topic we'll examine, you worked with systems of equations in Algebra 1, and you had several different techniques for solving a system of equations. You, of course, had substitution method, you had elimination method. We've been using those already in some of our homeworks when we've needed them. You also had a graphing method where you would graph both lines at the same time. Wherever they crossed, that was your answer. That was your solution to the system. Well, we're going to look at something similar to that. Not so much with the goal of solving the system, but the goal of asking what kind of solution are there. If the lines are parallel, there is no solution. We could have lines that cross, in which case that one point is the solution. And it's also possible for you to have a line fall perfectly on top of another line. And when this happens, it's called coinciding. Well, those, of course, have an algebraic structure to them. We already saw that when the slopes are the same, you get parallel lines. The big difference, though, is if you also have the same y-intercept, if it's the same slope and the same y-intercept, you get coinciding. If it's same slope, different y-intercepts, that's when you get parallel. And of course, if the slopes are not the same, if you get different slopes, that's how you get intersecting lines. And we discussed before that if it happens to be negative reciprocal, that's perpendicular. So, look at the lines. Are these parallel? Do they intersect? Or do they coincide? The first thing to check is the slope. The slope is 3. And the slope is negative 3. Are the slopes the same number? No. Because the slopes are different, those are intersecting lines. Done. There's no writing at all. It's just, do you know the correct location to look in the line? Do you know what the actual relationships are? Consider here. Well, with our first one, we have a slope of negative 1 over 3. Second one's going to be a little bit tricky because you notice that this one's not in the format of y equals. We need it to be in either point slope or slope intercept form. That way we can actually know what the slope is. So either way, we can't have coefficients in front of the y. So we'll just divide out by 6. When we divide by 6, this becomes negative 2 over 6x plus 12 over 6. Simplifying those two fractions, we get negative 1 over 3x plus 2. So, look at the slopes. Are the slopes the same or different? They are the same. That means we have two options. They can be parallel lines, or they could possibly be coinciding lines. To figure out which one, we then need to look at the y-intercept. Are the y-intercepts the same? No. So we have lines with the same slope, different y-intercepts. When that happens, the lines are parallel. Now, for this problem, of course, we would make the observation that, once again, this is something that's not fitting point slope. It's not fitting slope intercept, so we would have to manipulate it a little bit. And so the first thing we could do is to add over to 4x by adding 4x to both sides. We'd be able to get 2y equals 4x plus 16. Of course, I did not take 16 plus 4 because they're not like terms. We can't combine them. When we then divide out by 2, be able to simplify these so that we get y equals 2x plus 8. So the first one has a slope of 2. Looking at the other line, it also has a slope of 2. So immediately we know that they're not just intersecting because the slopes are the same. Now we have to determine if the intercepts are the same also. In order to do that, we're going to have to use the distributive property on our set of parentheses. When we multiply across, we get 2x minus 2. Adding 10 to both sides then shows us y equals 2x plus 8. And of course we would notice then their y-intercepts are the same. So when we get same slope and same y-intercept, that means that these are coinciding lines. It's actually the same line written with two different equations. When we graph them, they would fall perfectly on top of one another. The red line and the blue line. Come on, blue. And that takes us back to our objectives. We've seen how to graph lines, whether it's slope-intercept or point-slope. Both of them give you the beginning location with a point, and then slope you just have to count in the right direction to get more points and connect the dots. We saw that to classify lines, we would look at the slope, we would look at the y-intercept and see, based on conditions, parallel, intersecting, or coinciding.